Drilling holes happens all the time, or you need it to happen all the time. And drilling holes is sort of a subtractive process, isn't it? When you drill that hole, if you didn't get it right, you've still got the hole. So that's one of the reasons I like working with metal, is because if I drill a hole in the wrong piece with metal, I can weld the hole full and grind it off. And at least with steel, it is as if it never happened. Not so with wood. And in any of the mediums, drilling holes has sort of a set of tricks. To every other aspect of any other trade, you get better as you do it. And there are some things you'll learn about drilling holes with your drill motor that are sort of specific to your tooling and your skill set, but there are some rules of thumb that are nice to know. So what we're talking about here is not drilling big holes. We're not talking about using a drill press in a machine shop, though we will address that in a future video. Who cares? Today we're talking about drilling with handheld electric drill motors. What I have here on this table are drill motors and drill bits, drill motors and drills. The terms in real life are interchangeable. Technically, these are drill motors. They're the motors that turn the drill bits, the drills with the bits at the point of intersection between the tool and the work. But it's interchangeable. We're not making a big deal out of it, but you might think about it moving forward. I've got 3 handheld drill motors here. There's not a wide range of radically different drill motors you can buy. I mean, there's whole hogs and there's right angle drills, and there's a variety, and there's a wide range of power, but they all just spin these cutting implements. And the cutting implements are specific to different materials and different applications. So you're combining these things based on what you're trying to do. Speaking of the drill motors, if you just had to buy one, if you could only own one of these 3 tools, it would be this one. Because you can do almost everything that you can do with this, although not near as conveniently. And you can do a large percentage of what you can do with this, though eventually you would tear the guts out of this because this has so much more power. So if you just had to buy one, buy a 1/2-inch pistol configuration, lots of amp draw, Milwaukee if you want, with a screw inside handle. Talking about drilling wood, even though some of these bits will drill wood or steel, let me just kind of try to point out some of the different characteristics. This is a representation of a pretty early wood drilling bit. See, it was pretty thin in section and twisted into a fairly tight screw. So it essentially has the 2 flutes that are described up here. You have 2 bits, a worm pulling it through, and then these little 2 ears, I don't know what they're called, but they score a continuous boundary around the circumference to loosen up the chips. The worm is kind of tight, but that's a sort of an early chip auger and a brace and bit. These are modern variations on the same theme. Got a worm. The worm centers the hole and pulls you into the work. Saves pushing on your drill motor a little bit. If this is sharp and engaged in solid material, it'll pull you right along. This has a single bit, and it doesn't have that raised up ear for scoring the circumference. Apparently it turns out you just don't need that for rough work. The screw is more elongated than it was on that other one, and in a powerful drill, that's going to make a big hole in a hurry. Here is, I don't know who the maker of this is, it's 5/8, a spade bit. Here's a bigger one that includes the little ears on the edge to define the circumference. This is a very primitive and very fast and very effective drill bit. You can get close enough to centered. This is close enough to sharp. The score around the edges helps the chips relieve and come flying out of there, and they will fly out of there. And when it comes out the bottom side of the board, it blows out a terrible hole. All of these can be sharpened. A 3-cornered file that'll fit in there, you can just brush that right off and sharpen it. It's the same with this. You sharpen this from the inside so that this remains flat and all of the material is removed from the inside of that bit. You can see that that's been sharpened a few times in its life. Here's a fairly recent technological leap as far as I'm concerned. Irwin makes these things. Speed bore, I think they call them. Look how tall the threads are on that worm and how aggressive. There's 3 flutes. How in the world is that machined? I can't even imagine it. But boy, are they sharp. Those ears are sharp, and this will pull a hole through a board so fast you can't get off the trigger before you're out the other side. It also takes a lot of power to turn it. I sometimes worry about this octagonal tang twisting off because of the horsepower that's being eaten up right here because of how fast it pulls into the wood. Great bits. These are a standard 2-flute machine type bit. This will drill steel or wood. 1/2 inch, and I don't know what size this is. This is, it's about rubbed out. I think this is about 1 1/16 or something. If you're going to drill wood, you can drill wood. If you're going to drill steel, you can drill steel. You have to center punch with something like this because that large point of contact will walk all over your piece before it actually defines where it's going to drill. These are sharpened on the outside of the flute rather than on the inside like on the ship auger. These are sharpened out there on that face, which is a trick that I only barely can do. Continuing on the theme of a wide range of drill bits, that's for woodwork. These two are also for woodworking. This is drilling specifically a pilot hole for a number 12 screw. It's tapered. It is widely spaced on that screw, and you just run the hole in there so it's going to approximately conform to the taper of your screw, and it even countersinks for the head, all in one shot. And then this will drill a center hole in a piece of hardware. Think of a set of cabinet hinges that you need to center the pilot hole inside of an opening in a hinge or in a pull or a lock set or something. As it spins, you can push that in contact with the work. It holds it centered in the appliance and puts your pilot hole in. There's a wide range of specialty drill bits, and we haven't even begun to talk about the bits available for drilling steel and other metals. Now this is an example of a hole saw. A hole saw is a combination of a drill and a saw. You don't often think of saws creating round holes, but a hole saw certainly does. And this is a 2 3/16, I think, diameter hole saw, which is a standard diameter for a lock set, for putting passage locks and that sort of thing in doors when you're hanging them from scratch. There are not a ton of ways to get hurt drilling holes. And most of the ways you get hurt drilling holes is with the bit hanging up in the work and the drill motor continuing to spin with your finger on the trigger. You can get badly hurt that way. So always keep a really good grip on your drill motor. Try to only drill in a position where you're balanced and you're safe and you're secure. When you're drilling big holes in big pieces of wood, pull the bit out often so that the chips clear, so they don't just pack in tighter and tighter and tighter until the whole bit is just stuck, wedged into a hole in a big old beam, and you can't pull it out because the chips are packed in so tight the friction won't let it come out, and the drill's not strong enough to start it in reverse. So clean the hole often. That's also true drilling deep holes in steel, by the way. But in any case, safety, eye protection's good, stability's good, keep your fingers out of the way, and be ready and know what you're going to do when things bind up. Now, when you're drilling wood, generally, there's not a lot of ways to hurt the wood if you get the hole in the right spot until the bit begins to approach exiting on the back side. And then you can hurt your project a lot. So it looks great, right? It's a Forstner bit, nice tight circumference. We turn it over expecting to have a beautiful hole, and instead, as the bit emerges from the cut, the veneer just spalls right off the edge. That piece is wrecked. If that was drilling on a cabinet door, you just have a tough conversation with your boss coming up when you get back to the shop. So when you're drilling wood, especially a finish type hole, nobody cares about a mud sill around a house or a glue-lam beam that's 20 feet up in the air. Nobody cares about backing up your piece when you're drilling. But if you're drilling a finished piece, it needs to have a backer like this. Look at the difference between that and that. You're supporting the surface as the bit is pushing through. Let's see how we did on the back side of this piece of 3/4. Look at that. Pretty nice. But on the back side of this piece of 3/4, we have splinters hanging off. I just pulled them off. Can you see that that's just blown up? If all you have is a set of machine bits, this type of a standard multi-purpose drill bit, and you have to drill a specific location in some wood, I mean, look at the problem. How do you determine where that's actually going to drill in a piece of wood? You put your X on there, but, well, one way is to take a very little bit, drill a little tiny pilot in that piece of wood, if this is all you've got. Or maybe you'd be comfortable with an 1/8 inch and drill a hole, and then graduate up to the bigger pieces. You can certainly do that. Let me put this away so I don't lose it. That is one of the reasons that metal cutting bits are not ideal for woodworking, because a woodworking bit is going to have a very refined spur so that you can get to an exact spot and start it. When you're drilling wood, especially in some sort of a finished project, not only do you have to worry about starting the hole in the right location, not only do you have to worry about not blowing up this finished veneer at the exit, but you have to make sure that the bit comes out in the right place, just like it goes in at the right place. Usually that denotes making sure that you're drilling square to your work in both axes. So the question of how to drill a square hole it deserves its own extensive treatment, okay? But there's a wide range of jigs and things that you can build, and when you have confidence in your own ability to judge square, that's pretty good. But even as something as simple as a 4x4 block that's cut nice and square as a point of reference for square in both directions. You know, I mean, that can help you. Now that's primitive, and it's fast, and it's not perfect, and you can rig something up, or we'll teach you another way to do it, but be careful and you can drill a square hole, and then be careful when it emerges, and you'll be happy with what you've done to your project. Let's talk about drilling in steel. One of the first obstacles that steel presents that wood is oblivious to is that a steel bit does not have that little spur like wood bits tend to, that will help you hold the drill exactly where you want it to be as you begin to drill your hole. So to compensate for that, you center punch. You take a center punch and put a starting mark in your steel. And you can lay it out, and you be as careful as you want to be with your measuring. And what it boils down to is you're putting a little depression that your drill bit will come to rest in, so you know that the center of your hole will be in a particular place. I'm going to put 2 or 3 of them on there because we're going to drill a few holes. The sharpness of your bit in cutting steel or drilling a hole in steel is really critical, because as hard as it is to push a sharp bit through a piece of steel by hand, it's way harder to push a dull one through by hand. It's easier to drill a smaller diameter hole. So a pilot hole, when you're drilling by hand, is almost always the way to go. Pick something small enough that you have a chance of pushing it through. Try to drill below your waist if you can, and don't spin it too fast. Now a comment. If you're not pulling any chips or shavings out and you're not cutting, don't keep trying, because it's not going to work. This bit's not terribly sharp, and so we'll put a little oil in here. A sharp bit requires very little oil because it's cutting. A dull bit requires a little more oil because it's rubbing. Now you may notice this drill will turn fast. I'm not doing that. It doesn't help to over-rev a drill bit through a piece of steel. You just increase the friction and increase the heat. You only turn it as fast as you need to begin to produce chips. Now I'm just about to emerge. You see, that's the first actual shaving. That's because the bit is beginning to penetrate the bottom. There's less resistance and it's pulling a bigger shaving. It's right now that bits tend to hang up and break off. So back off on the pressure on your drill motor. And we're through. Let's visualize what's happening as this is being pushed through that steel. It's cutting, ideally, if it's a sharp bit and if both of the flutes are ground to the same angle. It's cutting on both sides more or less uniformly all the way across the length of that bit. In this case, that's probably 5/16 of an inch. So there's almost 5/8 of an inch of material being removed, just a couple of thousandths per revolution as it goes on through. But as soon as the tip of that bit begins to emerge on the back side of the piece, in just a few moments, you go from pulling a net 5/8 inch wide cut to something that approaches 0. And so in the last few revolutions, the weight of the drill, the weight of your body, the horsepower of the drill is being discharged on a narrower and narrower little bit of resistance. And it'll dig deep. It'll pull deep into the steel, deep enough in the last moments that sometimes it will break off the edges of the bit because it's pulling off way more material than it was intended to deal with as it emerges from the cut. So as you can feel the bit beginning to emerge, back off on the pressure so that you don't end up snapping the corners off your bit, or sometimes the bit right in half, just as you should be emerging with a hole being fully drilled. So that hole, 1/4 inch, will make a pretty good pilot hole for the 1/2 inch hole I'm going to drill next. One of the things I like about this drill is I can actually bend over this side handle while I'm pushing down on the D handle and get a big portion of my body weight onto the drill itself. Let me give that a little oil. Okay, it's just about to emerge, so I back off on the pressure, pick up on the speed, oop, and still it's stuck. Can you see that as it was drilling through and it was down to just a very thin amount of steel left, it suddenly penetrated the whole distance and began to cut all the way to the perimeter and remove what is really too much steel. I'm going to go to high speed. So I went to high speed and a very, very light feed and got through there without tearing the world up. So these bits are 2-stage. Can you see that the pilot hole is cut right in there? So that instead of drilling 2 holes, you drill 2 holes with 1 bit and emerge with what you need. The angles are all different, the grinding is complex. I can't resharpen these, but man, are they neat. Here I am trying to tell you tips about drilling holes and trying to articulate these things, and I realize in a lot of ways I don't really know why I'm doing what I'm doing sometimes. And what that sort of presents is that really the way to do this is by doing it. But as you're doing these things, be thinking about what is happening. Try to visualize what is happening at the point of contact with the drill bit and the steel. Think about what the sound of that drill means. Become really sensitive to the resistance you're giving to the torque on that drill motor. It's a function of the senses and not just the eyes, but all the senses can come. You can smell when the oil's getting hot. So I guess the takeaway is there's no substitute for doing this. And there's no substitute for thinking about it while you're doing it. You can cut years off of your development in these things just by applying yourself in the moment each time you do it, and do it as often as you can. I hope this has been worthwhile. I don't know if it has been, but I hope it has, and in any case, thanks for watching.